Good day, dear friends. Hope all of you are doing well. I'm Pranasish and I'm back with another problem related to an accelerating sprinter. This is a sprinter of mass m. The sprinter has an acceleration directed to the right, and the magnitude of the acceleration is a. Our objective will be to find an expression for the angle theta which the sprinter makes with the vertical. For simplification, the hands, the head and the lifted leg of the sprinter have been removed and the structure has been redrawn. The sprinter has a horizontal acceleration a directed to the right. We are going to find an expression for the angle that the sprinter makes with the vertical. This is the point of contact between the grounded foot of the sprinter and the ground. This is center of mass C of the sprinter. X is the horizontal distance on the center of mass of the sprinter from the point of contact, and Y is the vertical distance of the center of mass of the sprinter from the point of contact. We are going to find the expression for the angle that the sprinter makes with the vertical, not in an orthodox way. We'll apply the idea of pseudo force and the idea of the moment of force. Let us consider that the point of contact between the grounded foot of the sprinter and the ground is a non-inertial frame of reference having a horizontal acceleration of magnitude a directed to the right, and the sprinter is stationary related to this non-inertial frame of reference. Now let's identify all the forces acting on the sprinter at different points. The force of gravity acts on the sprinter vertically downward at the center of mass, and it's given by W, and W is equal to the mass of the sprinter multiplied by the acceleration due to the Earth's gravity. The pseudo force experienced by the sprinter in this non-inertial frame of reference in the form of the point of contact is given by F, and F is equal to the negative mass of the sprinter multiplied by the acceleration of the point of contact. For the time being, we ignore the negative sign and take only the magnitude, the mass of the sprinter, and the acceleration of the point of contact, the non-inertial frame of reference. The force of static friction acts on the sprinter through the point of contact directed opposite to the direction in which the grounded foot of the sprinter tends to slide. So the force of static friction acts to the right, and let the magnitude of this force of static friction be small f. The normal force acts on the sprinter through the point of contact vertically upward, and let it be denoted n. So F and N are the two other forces acting at the point of contact. Now let's take the moments of all the forces acting on the sprinter about the point of contact. The moment of a force is an axial vector which creates a tendency in a body to rotate, and the magnitude of the moment of a force is the magnitude of the force multiplied by the perpendicular distance of the line of action of the force from the point about which the moment is being taken. Let us consider that the moment of a force which tends to rotate the sprinter in the clockwise direction is positive, and the moment of a force that tends to rotate the sprinter in the counterclockwise direction is negative. The moment of the force of gravity about the point of contact is given by tau 1 is equal to positive. Why positive? Since the moment of the force of gravity about the point O tends to rotate the sprinter in the clockwise direction, the magnitude W multiplied by the perpendicular distance of the line of action of the force of gravity from the point of contact and its x is equal to plus mgx. The moment of the pseudo force about the point O is given by tau 2 is equal to negative. Why negative sign? The moment of the pseudo force about the point of contact tends to rotate the sprinter in the counterclockwise direction. The magnitude F multiplied by the perpendicular distance of the line of action of the pseudo force and its y, right, y is equal to negative mass of the sprinter multiplied by the acceleration of the point of contact. The moment of the force of friction is given by tau 3 is equal to 0, since the line of action of the force of friction passes through the point of contact. The moment of the force, the moment of the normal force exerted on the sprinter by the ground is also given by tau 4 is equal to 0, since the line of action of the normal force also passes through the point of contact. All the moments of the forces exerted on the sprinter are at equilibrium, since the sprinter rotates in neither direction. Thus we can write tau 1 plus tau 2 plus tau 3 plus tau 4 is equal to 0. In place of tau 1 we write plus mgx. In place of tau 2 we write minus may. In place of tau 3 we write 0. In place of tau 4 we write 0 is equal to 0. Therefore, from this equation we get x divided by y is equal to a divided by g. From this right angle triangle, we see that x divided by y is equal to the tangent of the angle that the splinter makes with the vertical, and so we can write x divided by y is equal to a by g is equal to the tangent of the angle theta. And finally we get the expression for the angle that the splinter makes with the vertical, and it's given by theta is equal to arctan a by g. Hope you have enjoyed the way the angle that the splinter makes with the vertical has been deduced, and wait for the next video. Thank you.